Hi, I'm Dr. Gil Welch. In this Less Medicine, More Health short take, we'll consider how big data can produce little useful knowledge. Because there's such enthusiasm for big data, it's really important for you to understand why this imbalance exists. This is relevant to assumption number 4. It never hurts to get more information. The value of information seems to be a central tenet of the 21st century, but it's a tenet that confuses big data with useful knowledge. Did you know that Google has unveiled the details of an ambitious project that aims to collect genetic and molecular information on thousands of people? Or Health Nucleus will carry out a full analysis of patients' genomes, sequence their gut bacteria or microbiome, analyze more than 2,000 other body chemicals, and put them through a full-body MRI scan? Like an executive physical on steroids, according to Craig Venter, their founder. And here's the Health Secretary of the United Kingdom. You can get 300,000 biomarkers from a single drop of blood. So why would you depend on a human brain to calculate what that means when your computer can do it for you? There certainly are lots of data to collect on a single individual. You have hundreds of bits of physiologic data, thousands of bits of metabolic data, hundreds of thousands of bits of biomarker data, millions of pixels of structural data, particularly if we run you through a whole body MRI. And there are 3 billion data points in your genome. The idea is to collect lots of data on lots of individuals. That's what big data is all about. But doctors and patients aren't interested in big data. We're interested in something more important: information. And big data becomes information only if they lead to a reliable prediction of a patient-centered outcome. And in fact, doctors and patients are interested in something even more important: useful knowledge. And information becomes useful knowledge only if we have a course of action that reliably lowers that likelihood. So what you need to understand is that big data are not reliably useful knowledge. There are some major limitations to big data. First, relationships observed in big data often represent statistical noise, not genuine information. Lots of data equals lots of statistical noise. The problem was elegantly laid out by Canadian statisticians a few years ago in a study of astrological signs in health. As you know, there are 12 astrological signs, and they related them to over 200 admission diagnoses to hospitals in Ontario. They had over 10 million admissions. They found lots of interesting findings, like Leos were significantly more likely to suffer from digestive tract bleeding, or Sagittarians are at elevated risk to break their arms. Not that anyone actually believes that astrological signs are responsible for specific hospital diagnoses. Okay, maybe someone does, but we don't believe him. And you think the problem's bad with 12 astrological signs? Try 300,000 biomarkers, or millions of genetic variants. The next problem is that big data may provide genuine information, but the information may be too weakly predictive to be genuinely important. Weakly predictive information does not equal clinically important information. What do I think of when I think of clinically important information? Well, how about like the patient smokes? That is associated with a 10 to 30-fold increased risk of dying from lung cancer. What do I think of when I think of weakly predictive information? Oh, something like the president eats bratwurst. Yeah, processed meats, 18% increased risk of developing colorectal cancer. By the way, the corresponding percentage increase in risk from smoking, well, it's 900% to 2,900%. Now, let's be clear, the human genome does contain some clinically important information. The BRCA1 and 2 mutations, for example, carry substantial increases in the risk of breast cancer and, more importantly, ovarian cancer. The mutations associated with Lynch syndrome carry a dramatically increased risk of colon cancer. And multiple endocrine neoplasia. You're almost guaranteed to develop an endocrine tumor over your lifetime. But in these examples, the signal was so strong there was no need for big data. We knew these mutations existed simply from observing the patterns in families. That's not to say it's not useful that we can now identify the mutation. But what are we mainly identifying now? Stuff like maybe your genome shows that your risk of breast cancer is 42% higher than average, or your risk of Alzheimer's disease is 25% higher than average, or your risk of lung cancer is 55% lower than average, or your risk of heart disease is 18% lower than average. Oh, by the way, there are confidence intervals for each one of these things, and there's considerable debate about the accuracy of each estimate. That leads to the third problem. Reactions to big data abnormalities may create more problems than they solve. Let's come back to weekly predictive information and ask yourself the question, now what? What should we do? Well, let's focus on that increased risk of Alzheimer's disease and decreased risk of lung cancer. Maybe you should start doing Sudoku puzzles and start smoking. No, I don't think so. The value of weekly predictive information is unclear, but it will clearly scare people. More concerning risk information will lead to more testing. More testing will lead to more referral. More concerning risk information, it will lead to more referral. And more referral will lead to more testing. And more testing and more referral will lead to more concerning risk information. And all this will lead to more unproven interventions. It'll be a haphazard process. By the way, the problem of weekly predictive information is not confined to the genome. You have an elevated biomarker. What should we do? Operate? You have a concerning immunosignature. What should we do? Radiate? You have a funny-looking intestinal microbiome. Oh, this is all beginning to sound like I'm not going there. But do I really need to worry about my gut flora? The assumption is it never hurts to get more information. But what we're really talking about is more data. And the disturbing truth is, data overload can scare patients and distract doctors from what's important. I hope this helps. Thanks.